So 7.3 notes is about probability. So in our quick write, we kind of already looked at what probability is. Put your name on here and put your hour on here. It is currently second hour, whatever your name and your hour is. Don't just put Mrs. Ho in 2. Okay, so probability today we are going to find by the number of favored outcomes, so what we want to happen, divided by the total number of possible outcomes. So Inigo on his quick write gave us an example of rolling a 6 on a dice. It's going to be 1 out of 6. He then turned that into a percentage for us, which was super helpful. Okay, so probability is the likelihood of an event happening. So if I say there is a 100%, which probability that it is going to rain, that means it's already raining outside, basically. So the probability of something happening is how likely it is. The probability of me winning the lottery is low. The probability of me tripping over my own feet while I walk up and down these aisles and your backpacks is high. It always happens. We are going to turn our probabilities into percentages. So we're going to take our probability, which will be a fraction. We will take that fraction, we will multiply it by 100, and that will give us the percent chance of occurring. And the big reason why we're turning things into percents is because percentages are always out of 100, so it is always clear and it's easy to compare when everything's out of the same 100%, okay? It's easy to compare 80% versus 90% versus 100% versus 8 out of 12, 9 out of 15, and 13 out of 42. You can't like compare those grades as easily because if the denominators of the fraction are different, it's not as easy to compare which ones are good and which ones are bad. So we're going to take our probability, we're going to multiply it by 100, and that's going to give us the percent chance of something occurring. Any questions about this? Okay, it says it on your assignment. It does not say it on your notes because I'm saying it on your notes right now. We are going to round to the nearest whole percent today. So we rounded to the nearest hundredth back on 7.1, but today we're going to round to the nearest whole percent because if we're multiplying by 100, rounding to the nearest percent is rounding to the nearest hundredth. And if we were to leave 2 numbers after the percentage sign or after the decimal, that would be like rounding to the nearest thousandth, which is way unnecessary. Okay, so our first example says a card from a deck of 52 cards is drawn. We want to find the probability of drawing a black card, the probability of drawing a card with an odd number on it, and the probability of drawing a card that is not a spade. And I just realized I made a mistake on my answer key here. Not that you guys ever see this answer key, it's mostly for me. Alright, so first of all, what we learn every year when we do this lesson is that you guys don't spend enough time playing card games. Which is probably good because we shouldn't be gambling, but also some card games are fun. So, let me find my Google Images deck of cards so you guys can see a deck of cards. Images. Because you need to see this all laid out to understand a deck of cards. I think this is the one I always use. Save image. Okay, I'm trying to open this as just an image. Save. Okay, so that way I don't have like a gross web browser. Okay, I just downloaded this. The name of the download is download. It is in my downloads folder. Okay. Alright, so a deck of cards is just as soon as this opens. When we have a 3-day weekend, the day coming back feels like a super Monday. It's more powerful than a normal Monday. And my computer is showing for it. Okay. I promise I'm just like trying to open on a... This is really not wanting to open. Alright. Oh, it finally went. It was just being real slow. Remember how I got a new computer last week and it was supposed to work better? It's somewhat working better. Okay. Okay. Oh. We're almost there. I feel really happy for everyone who gets to watch this video.
Here you're sitting for 5 minutes.
Yep.
Did you not pause it? Is it just so...
No, but it's still going. If you guys have to... Oh my god, and then my photo I downloaded is so blurry. Okay, it doesn't really matter, I guess. Hey!
Downloaded a virus.
No, the virus would have been way faster. It would have been... Okay, so, this is a deck of cards. You can see what you need to see from it. Alright, so... Please stop talking now. Alright, a deck of cards has 52 cards. So that is the first thing that you need to know. A deck of cards has 52 cards. There are 4 suits in a deck of cards. There are 13 cards in each suit. So 13, 26, 39, 52. In a deck of cards, or in each suit, the cards are ace, which in some games is worth 1 and in some games is worth more than a king. But ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king. I said that. Yeah, no, I said that in the right order. Jack, queen, king. Okay, so when we are trying to do our assignment or our note sheet that we are trying to do right now, we are looking for the probability of picking a black card. So all of our diamonds and our hearts are red. All of our spades and our clovers are black. They're not called clovers. Are they called clovers?
No.
Clubs, thank you. Clovers is what it's called when you're picking 4-leaf clovers. Okay, so out of all of these cards, 13 plus 13, 26 out of the 52 of them are black. I don't need to use that complicated of a fraction though. What fraction of these are black?
1/2.
Just half of them. Because 2 out of the 4 suits are black, so 1/2 of these cards are black. Okay, this is the one single percentage that I expect for you to be able to do without a calculator. What is 1/2 as a percentage? 50%. Okay? We are in high school, we should know that. If you don't know that, now you do. So, if I wanted to do that with a calculator, I wanted to double check myself, 1 divided by 2, and then I would multiply by 100, and I would get 50%. If I did the 26 divided by 52, I should still get 50%. Okay, next one is the probability of drawing a card with an odd number on it. So, I accidentally clicked off. My cards that have an odd number on them are the 3s, the 5s, the 7s, and the 9s. So I could count that as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 out of all 52. Or I could know that out of every suit of 13 cards, how many of those 13 cards have an odd number on them? So, ace isn't a number. Is 2 odd? So we've got 3, 5, 7, and 9. So just 4 out of every 13. So we could do 16 out of 52 here, or we could do 4 out of 13. Either way you do it, you're going to get the same fraction. So now, let me scoot my little tiny deck of cards out of the way, which you can barely see, sorry. If I were to do 4 divided by 13, I'm going to get a decimal. I'm not going to do anything about rounding yet. Then I'm going to multiply it by 100, and I get 30.7. And I decide, do I keep it at 30 or do I round up to 31? Does 0.7 round up or stay the same? Round up. So this is going to be 31%. Because we're rounding to the closest whole percent. Hey, the next one, please stop, is the probability of picking not a spade. So out of all of my cards, the hearts, sorry, those are diamonds. The diamonds are not spades. The hearts are not spades. The clubs are not spades. So 3 out of the 4 suits are not spades. So the likelihood of me picking not a spade is 3 out of 4. What percentage is 3/4 going to be? 75. Yep. Hey, so every year we talk about this deck of cards problem because there's one on your assignment too. I'll find a clearer photo and pull it up for your assignment. And like, oh, but they don't know how many cards are in a deck of cards. Well, we think it's important that you do because like that's like just like a random trivia thing that you should know. So, all right, the next question we have is easy, because we give you the numbers. So we tell you that in a handful of starbursts, you have 1 red, 4 pink, 5 yellow, and 10 orange starbursts. So the first question is, how many total starbursts do you have? 20. So if we were to add these up, 1 plus 4 is 5, plus another 5 is 10, plus 10 is 20. So if you need to put a little note so you know where you got that, I've got 20 total. All right. The probability of picking a yellow starburst is going to be 5 out of that 20. So we'll do 5 divided by 20. Even if a fraction can be reduced, you don't need to reduce it because we're about to turn it into a percentage. So you don't need to reduce it and turn it into a percentage. 5 divided by 20 is 25 or 0.25. Multiply by that 100 to get our 25%. Which makes sense because 5 is a quarter of those 20 starbursts. Okay, the probability of picking red. So if red is your favorite color, there's only 1 in the whole handful of them. Likelihood is low. So that's going to be 1 out of 20. Okay, 1 divided by 20. Then make sure you multiply by that 100. This is 5%, not 50%, because it's a super low single-digit percentage. Okay, then this sentence or this probability is based off of my favorite colors. So I like yellow or red. I don't like orange and pink. So the probability of not picking yellow or red and picking something I don't want, the probability of picking yellow or red would be 1 and 5, so 6 of them. The probability of not picking them is the rest of them, so 4 and 10. So that's going to be 14 out of 20. You could find this probability by finding the probability of picking yellow or red and then subtracting it from 100, or you can do it this way, it's faster. So 14 divided by 20 is 0.7. Multiply that by 100, that is 70%. Not 7%, 70. All right, any questions so far on the 2 examples of simple probability we've seen? Okay, so this is simple probability, meaning it's just one event happening. We just want to know what the likelihood of that one single event is. We are going to look at one more type of probability, which is compound probability, because in life, we're not worried about just one thing happening usually. So compound probability is the probability of 2 independent events occurring together. So the probability of me tripping over your backpack and the probability of you being in the bathroom while that happens, which would be like really hard for us to find, so we're not going to do that. They have to be independent events, so they have to be unrelated to each other. So it can't be the probability of you getting ice cream after school and you having a doctor's appointment, because if you had a doctor's appointment, you had to get shots, at least in my family. It was the only time I ever got ice cream, I was more likely to get ice cream. So it can't be something that's going to depend on the other thing. So independent is the outcome of one event does not affect the other. Okay? So the compound probability of 2 events, probability of A and probability of B, We just multiply their probabilities together. So our example on here that we're going to do some compound probabilities for is a single, just normal 6-sided dice. We didn't put that on here. 6-sided die is rolled twice. So we roll a die once, stop, we roll it again. Whatever you get from the first roll has absolutely no impact on what you get from the second roll. It's an even roll the first time, an even roll the second time. So the probability of rolling and getting an odd number on a dice, it's 1, 2, 3, 4, 5, 6. How many of those are odd? 3 out of 6. So for a probability of odd, you can either put 3 out of 6 or 1/2. Which do you guys want to do? 1/2? Okay. So we're going to put that on our first line as our first fraction. So the probability of rolling and getting an odd number is 1/2. Then, what is the probability of rolling and getting less than 5? 4 out of 6. Because it would be 4, 3, 2, and 1. So I'm going to write that down here so we know where we're getting that from. 4 out of 6. Okay. So I've got 1 out of 2 and 4 out of 6. Any questions on my initial percentage or my initial fractions? Okay. So quick refresher to, I don't know, 5th grade? I don't know when you guys learned how to multiply fractions. But when we multiply a fraction, we multiply the numerator, we multiply the denominator. So 1 times 4 is 4, and 2 times 6 is 12. So now we have 4 out of 12. And that is what we are going to turn our percentage, or turn into our percentage. 1/3. So 4 divided by 12. Yes, it's the same as 1/3. But we want it as a percentage. We'll multiply that by 100. And we will get 33.3. Does that round up or stay the same? Stay the same. So that is a 33% chance of those two events happening. Okay, any questions at the moment? Okay, the next one, the probability of rolling not a 2 both times. What's the chance of us not rolling a 2? 5 out of 6. Everything else is, there's only 1 2 on there if it's a real dice that has real numbers on it. So the probability of us rolling not a 2 is 5 out of 6. So that's going to be 5 out of 6 times 5 out of 6. So for the top of my fraction, I'm going to multiply my 5s together. 5 times 5 is 25. And for the bottom of my fraction, I'm going to multiply my 6s together. 6 times 6 is 36. So I'm going to have a 25 out of 36 chance. So let's say you're playing a game, and if you roll a 2, you lose a turn, or the other person wins or something. So you don't want that to happen. 25 out of 36, 0.694, multiply that by 100, 69.4. Does that round up or stay the same? Stay the same, 69%. Hey, any questions? Last one, the probability of rolling only even numbers. What is the probability of rolling an even number? 1/2. So we could do 3 out of 6, or we could just know that that's 1/2, and that'll make our multiplying our fractions easier. So if we do 1/2 times 1/2, then 1 times 1 is 1, and 2 times 2 is 4. So we get 1/4 instead of 9/36. If you already did it and you got 9 out of 36, that's correct. You're going to get the same percentage. What percentage is 1/4? 25%. That, if you know any percentages, 25, 50, 75, $1, 100 would be the ones I would expect you to know. Hey, any questions? Okay, I'm going to stop this very chaotic recording. Sorry if you were listening to this recording and you had to wait for everything that you had to wait for, but also not sorry. You're welcome that I record my notes.